Alright, let's pick up where we left off. I've done a lot of experimenting between when I last set this first part up and with what I want to do now. Thinking ahead a little bit, first off, I don't want to just call this the D6 because this is going to be all things. So I'm just going to call it dice. Sounds nicer than die, even though it's only going to be one. And that's going to be a very minor change. The reason being is I want to be able to switch between all of the different polyhedra that we're going to have, and we're going to change it with this model. So self.model equals cube, that's going to be okay to start. We're probably going to wind up changing a lot of these things. What I want to do first is I want to actually introduce the tetrahedron, or the D4, and in order to do that, we need to introduce a couple other things. This is called the Ursina mesh. And there's actually a lot that goes into it. Doing one mesh on its own is no big deal. Doing it as part of a class requires a little more typing. And what I'm going to start with is self dot, and we will call it D4, oops, that's DR in case you weren't looking, D4 dot verts for vertices. And like I said, I did a lot of experimenting. Now this isn't perfect, but this is the one that worked best for me. So all we're doing is doing the 4 3D corners of our tetrahedron. So we have 42, oops, actually need this inside parentheses as well. So 42, negative 36, negative 15. Let's clean that up so it looks a little nicer. There we go. That's one vertex. My next vertex is going to be negative 42, negative 36, negative 15. My third vertex will be 0, 36, negative 15. Well, this last one is the one that made the least sense to me, but after messing around with it a bunch, this looked better than anything else I had. 0, negative 12, and 48. Okay, so those are the vertices for the D4 specifically. Now, I also need what's known as the tries. So self.d4.tries, that's going to be short for triangles. And this one's really weird. This is just groups of 3 that set up the 3 points of any given triangle face that you're going to have. And really, we just need to connect each one to each other one, because that's how it works with the tetrahedron. So we're going to do 0, 1, 2. That's my first triangle. 0, 2, 3. 0, 1, 3. And 1, 2, and 3. Those are the 4 different triangles that we can make out of a tetrahedron. Next, we're going to have the UVs. So we're going to say self.d4.uvs. And I will be honest, I'm not totally sure what these do. I understand what UVs are, but I'm just going with what it showed me in the tutorial I had. So they had 1.0, comma 0.0. 0.0, comma 0.1. That's not right, is it? 0.0, sorry, 1.0, not 0.1. We have 0, 0, 0, 0. And the last one is 1.0, comma 1.0. Couldn't find anywhere where there's a good explanation of this, and when I tried messing around with the numbers, it didn't seem to change anything, so I'm just going to leave it as it is and not worry about it. Works is works, right? Finally, we have the normals. So we're going to say self.d4.norms. And again, I tried messing around with these, 2 bad results. So we have 0, comma 0, comma negative 1. And we're just going to multiply that. They have it like this, comma, times len self.d4.vert. So it's just telling me how many normals do I need. It's going to be that. And that looks pretty good to me. Hopefully that all works. Last thing we need is colors. And oops, let's make it d4.colors. And what I want to do is, actually, since we are in the trying around phase, let's try doing something like what they did there. So we're going to do color.random color, and we want to do that times of self.d4.verts. If that doesn't work, I'll have to come back and change that, but what the heck, I feel like experimenting here. Okay, so now what we're going to do is we're going to set the d4 model as this. So self.d4.model equals, this is going to be a mesh, and my vertices will equal self.d4.verts. My triangles will be self.d4.tries. My UVs will be self.d4.UVs, and my normals will be self.d4.norms. I'm going to go to the next line with this. I'm also going to clean this up a little because I did spaces in some places and not in others. Let's go for some degree of consistency. I went past that line there. Oh well, I'm not going to beat myself up about that too much. We have colors. So colors equal self.d4.colors. Missing one thing here. What am I missing? Oh, you know what? This isn't a mesh, it's an entity. And the model is equal to mesh. No, I think I had that right the first time. Because I said self.d4 equals model. The entity is going to be the actual die. So my model should be this thing right here, and I should be able to change that to this later. Okay, so instead, what I want to do, actually, go one line below. We're going to say self.d4.scale equals, and what did I make this? 0.02, so it's not too big. And then I'm always going to want it to be double-sided to be true. So self.double-sided equals true. I find that's a lot easier than trying to get all the faces to face the right direction. Okay. In theory, that will have worked. To just test it out, instead of going with self.model equals cube as it is up there, I'm just going to change it. One line below. This is not good programming, but I'm just looking to see if it's going to work. So let's go self.model equals self.d4.model, and then I also want to do self.scale equals self.d4.scale. And let's see if this works. If it doesn't work, then we'll know we have something else that we have to do. And if it could take a little bit longer, that'd be awesome. Nope. Alright, something bad happened. Dice has no attribute d4. Self.d4. This is... That shouldn't matter. Self.d4. All of those things. Dice has no attribute d4. Something missing, and that's just the error that it's giving me. Self.d4. Just out of curiosity, I wonder if I do something like self.d4 equals entity. Make it blank, see if that works. Of course, did all of my experimentation on it. It did work. How about that? Okay, I guess I just had to kind of declare it as a thing. I believe we said space rolls. There it goes. And it's got the grass texture instead of the colors. So let's see if we just kind of note that out. See if that'll look a little better. So it's fun when you try something and it works. Nope, I don't know why the colors aren't working the way I want them to. Well, let's just go back to the grass texture. We're not going to worry about the colors for right now. We're going to worry about the shape. I'm going to include the colors anyway. You know what? Change my mind. I'm going to do this the crazy way. Color dot random. I'm just going to put it in 4 times. Again. Bad coding. But if it works, is it really that bad? So let's see, I wanted to note out the grass texture again, right? Okay. So like I said, I did, there you go, that looks a lot better. Okay. I don't know why I wouldn't do it with the length times whatever. What's cool is because it's random is, that's a pretty neat looking color, I think. And if I run it again, I'm going to get a different looking color. See? All right, so that is for my D4. Now, let's also set one up for the icosahedron. Again, I'm just going to note these out for now, because I might want to reference them again later. So we're going to take up a lot more space here, and we are going to set up the icosahedron, which is going to be a lot more work, and we're going to do something that's really just truly terrible programming, and I'm okay with that. So we are going to start with, we need the vertices for the icosahedron, or the D20. So let's go self.d20 equals entity. Got to make that happen first, we discovered. Then we're going to say self.d20 dot verts equals. Now this one's going to have a lot. So we have 8500. We have 38760. And again, these probably aren't perfect, but they're close enough. As you saw, that tetrahedron looked, more or less like a tetrahedron. Well, it was a tetrahedron, just maybe not perfect. We have 382373. And 38 negative 62 45. We're going to have 38 negative 62 negative 45. And we are going to have 38 23 negative 72. 38 23 negative 72. Now there's actually 6 more to go, but I'm just going to move on to the next line for those. Okay, we have negative 8500. So you're going to see a lot of almost repeats here. We have negative 38 negative 760. We have negative 38 negative 23 negative 22. What did I say? 38, negative 23, negative 72. I don't know if that's what I said, but that's what it should be. Just 3 more to go. Hang in there. Negative 38, 62, negative 45. We have, let's see, where was I? 1, 2, 3, 4. Negative 38, 62, 45. And last but not least, negative 38, negative 23, 72. Okay, whew, that was a lot. In addition to the verts, we need to have the triangles. Now, to come up with all 20 triangles of the icosahedron, every time I tried to do it, I kept screwing something up, and I wasn't totally sure what was what. So, what I did instead is I imported itertools. And then, actually, that's not true. I did from itertools. And I imported combinations. And And the benefit there is, for this next part, I can say that, let's see, we're going to have, do I need self? Let's try self. Self.d20 dot tries raw, meaning all of the raw possibilities for the triangles, all of the vertices. And it's going to equal list of my combinations, and all of our possible combinations are 0, 1, 2, 3, oops, that's 32, 3, 4, 5, 6, 7, 8, 9, 10, and 11 make up for the 12 vertices that I have. And I want combinations of 3 things. So we're going to do comma 3. What this ultimately does is it connects every vertex to every other possible vertex. There's going to be a ton of stuff going on inside of our shape that we don't really need. Okay, sorry about that interruption. So this is going to be a lot easier from a programming standpoint, and I think that's, when you're just kind of learning this stuff, if you get it to work, maybe that's better. I'm sure I've mentioned my credo before of make it work, then make it better. Right now we're making it work. Later we'll make it better. All right, next thing we need is self.d20 dot tries list, and we're just going to make that a blank. And then we're going to do for I in self dot, oops, not 20, how about d20 dot tries raw. And what we're going to do is we are going to do self.20 d20, not 20, there we go, dot tries list, and we are going to append I of 0. Now remember, these aren't a bunch of things separated. It's not like groups of 3 like we have with our vertices. It's just a bunch of numbers. All right, where was I? Too many interruptions. All right, so we appended that, and I was saying that, we wind up with this list kind of like what you see up here. So I just need to append each piece one at a time. So we're going to have that, and then we're actually doing basically the same thing. So I'm just going to copy paste. There we go. And we're going to change that to 1. Change that to 2. Okay, so now we're appending all of these things that we're going to need. Next, we need our UVs again. So really all of these things I'm just copying from what we have here. Let's go, well, the scales can be different, but even that, I'll take it. So I'm going to copy these things and just change all those D4s to D20s. So that was the end of my loop. And that, whoops, I keep pressing the wrong button. All right, change that D4 to D20. I don't need to do anything else there. Change this D4 to D20 and this D4 to D20. Here for the colors, I have 4 and I want 12. I really don't know why it won't let me multiply like it did with the norms, but whatever. This will just take a moment. Color.random color. Color.random color. Oops, random color. And let's do that 6 more times. I'm sure I could do some sort of copy paste here, but it's easy enough. All right, and for our model, we're going to change all these D4s to D20s, and everything else should be the same. And then I just need to figure out what I had put down for the scale. All right, and the scale that I had selected for this one that I thought worked pretty well was 0.01, okay? And now let's cut these and put them below. I do that one more time, and I'm going to unnote them. And we're going to go with D20 instead. Alright, that was a lot of work. Let's see how this works. Cross your fingers. Dang it. Entity has no attribute tries. So I did D20, D20. How come it worked up there? Self.D4's entity. Oh, right, because I didn't use tries. I used this tries list. Okay, tries list. Oops, that is not an L. Now cross your fingers. You can see the part of the D4 behind it for some reason, but hopefully you can see the rolling icosahedron. That's something, right? I wonder why that other triangle's there. I feel like there's just one thing wrong with that. So here's something else I'm going to do. Just for the heck of it, let's go self.x plus equals 2. Oops, no space between those. Just going to move it off to the right a little bit and see. Yeah, I wonder what that triangle is doing there. That's bizarre, but you can see that the icosahedron, hopefully you would agree, looking pretty good. You can also see off to the side here, I still have it showing me numbers. So we have a lot of cleaning up to do, but things are working, and that's pretty cool. I'm not going to figure out why that triangle is going on right now. I'm just going to do one last thing and then call it a day, and I'll probably clean up stuff before my next video. The one last thing I wanted to do is just make a background. Our background is black, and Ursina makes it really easy to make at least one cool background, and it's as simple as just doing sky. Those 5 characters, capital SKY, open and close parentheses, will give you a sky background. I'm going to make it a little more complicated, set it equal to a variable, because on my update I want to rotation Y. I just want the sky to be moving slightly. So now we have a rotating sky and that one triangle that won't go away for some reason. But you can see my icosahedron rolling. Those are actually pretty nice colors. Maybe I should have selected those on purpose. Alright, well, that's going to be it for today. I will, like I said, clean this up before next time. We will add the rest of the polyhedra. We'll come up with a way to switch between them, and we'll also come up with a system where you actually get a result, something that's printed on the screen. So until next time, take it easy.